Alright, 3.4, section 3.4, graphing inequalities in two variables. Notice this time it says inequalities, right? Inequalities. So what's the difference between an equality and an inequality? Well, this entire chapter, we've been dealing with equalities, right? Equations. So only sign you'd ever see are equal signs, right? This is an equality, equation. Let's say that to an equation. I can actually turn the width down. That's kind of cool. So go back to color and then red, and that's called an equation. Right? Inequalities can have one of four different options, right? We've got less than, greater than, less than or equal to, greater than or equal to, right? So we've got less than, greater than, and we've also got less than or equal to, less than or equal, or greater than or equal. Sorry about my handwriting. Alright, so we've got less than or equal to, greater than or equal to, less than or equal to, or less than or greater than. So we have four different options. Alrighty, now when it comes to the graphs of these guys, when it comes to the graphs of inequalities, they're just a little bit more complicated, because let's think about how many things are equal to each other. Well, 2 is equal to 2. That's it, right? That's it at the end of the day. 2 is equal to 2. It's not equal to anything else. But let's think about how many different things are greater than 2. So there's 3, there's 4, there's 3.5, there's 3.219, right? There's a whole bunch of things. In fact, there's infinite number of things that are greater than 2. Excuse me. Okay, that's better. And the same thing goes for or equal to, right? All of these could also be or equal to. The only thing we have to add is 2. Right? So since we have so many things that can be greater than or less than or greater than or less than or greater than or equal to or less than or equal to, the graphs of two variable equations are going to be a little more, just a little bit more work to actually create. Just a little bit though. So let's, sorry about that, erase all this. Okay, let's start graphing these guys. So we've got this equation, this inequality, 3x plus 2y is greater than or equal to 6. Right? Now again, the steps to do this are right up here, if you forget, but I find it's much easier to just do it through an example, so I'm just going to do an example on the page. So over here, I'm going to rewrite our inequality. 3x plus 2y is greater than or equal to 6. Now, as it is, it would be incredibly hard to graph this, right? Even if it was an equality, it wouldn't be, we could do it via the y-intercepts, but I think we're all in agreement that the easier way would be to convert it to y equals mx plus b. So let's go ahead and do that. Let's convert this to y equals mx plus b. Well, I'd have to start, even if it's an inequality, I'm still allowed all the same rules. The only thing I have to watch out for, and maybe we can put this on the side up here, is watch out, little star. In an inequality, multiplying or dividing by a negative. That's the only other thing that would do anything, that would change how you would solve stuff when you're using an inequality versus an equation. All that does is flip the sign around. Let's flip the equality sign. So if I had, down here, I had to divide by a -2, then I would change it from a greater than or equal to a less than or equal to. That's the only other thing that would change. And that's only if you need to do it. If you don't need to actually do it, then you don't need to worry about it, right? But that's the only thing that could happen that you might want to take care of. All right. Other than that, we can solve this the same way. So I subtract the 3x to both sides. Yes, it's a negative, but I'm not multiplying or dividing. So I don't do anything to the inequality sign. It just remains 2y is greater than or equal to -3x plus 6. Same as if it said equal. Then I divide. Here I might have to worry. I'm dividing by 2. I am dividing, but it's not by a negative, so this sign does stay the same. So it stays the same. So we're good there. So I end up with y is greater than or equal to negative 3 halves x plus 3. Alright, now it's in a much easier form to graph. So let's start by graphing like it's equal. So let's graph like it is an equality. We'll start at 0, 3, right up there, right, because that's our y-intercept. Our y-intercept of positive 3. So I'm going to start there, right? B is equal to 3. So this tells us that it's 0, 3. And then we have a negative 2/3 as our slope. So again, we'll start at 0, 3. We're not going to start at 0, 0, right? We use our starting point at 0, 3. And this slope tells me to go down 3 and over 2. Down 1, 2, 3, and to the right 1, 2. Alright, so that's step number 1. Graph it like it's equal. I don't quite want to draw a line yet. Alright. The second step, and you can actually do this first if you want, is indicate whether you need a dotted line or a solid line. Dotted line is for inequalities that do not, so dotted line is for inequalities that are strictly less than or strictly greater than, so not the equal to's, okay? A solid line is for less than or equal to and greater than or equal to. So we can write that again down here. So dotted line goes for less than or greater than. And then for less than or equal to, greater than or equal to, we would use a solid line. Okay, so that's always our indication. So that's why we kind of want to pause before drawing this line here. Oops, I seem to have lost my other point. So we go down 3 and over 2, goes over there. Because if it was strictly greater than, we wouldn't want to use a solid line. Here it's also equal to, so we can go ahead and draw a solid line that connects these two. And of course we would go all the way across. And there we go. We have the first part. Alright, any questions so far? Please make sure you stop the video and get them answered. The last step is to shade one of the sides, because remember, just like when we saw with the number 2, there's only one thing that equals 2, but there's a ton of things that are greater than 2, right? So the same goes here. In fact, an entire half of our graph is going to be shaded, whether it's the top half or the bottom half, right? So either above this line is going to be shaded or below this line is going to be shaded, because there are a lot of things that are greater than 6. So we have to look at that. Let's say, okay, let's look at our y-intercept form, right? A lot of things greater than 3. Y, so these values over here, y, like up and down, is greater than these numbers. So it's greater than these numbers. Now that might be kind of hard to tell which side is the greater than side. Usually it's going to be, for greater than, this upside over here, this corner over here. But just in case, if you can't logically determine where it would go, you can use a test point. A test point. Any point you want. Now this is if it's not obvious, right? If you can see that this greater than side would be up here, that's great. Go ahead and shade. But just in case, if you're even a little bit concerned, then you want to use a test point. Any point that's not on the line. So I think I'm going to use this pink point right here. I'm actually going to use something below. Now let's just use this pink. I'm going to use this point right here. Notice it's not on the line. And this is the point 0, 1, 2, 3, 4. 0, 4. Right? So I'm going to use this point. I'm going to take this test point, 0, 4, and I'm going to plug it in to my equation here. Now if I plug this test point in and to y is greater than negative 3 halves x plus 3, if I were to plug this test point in and I got something that made sense, then that is definitely the side I want to shade. The shaded side is supposed to represent all your true values, right? Your true values. So if this value is indeed true, I should get something that makes sense. Let's see if that actually happens. So 4 is greater than negative 2/3 times 0 plus 3. And there's a reason I chose this point, is because I wanted 0 to cancel with this stuff. That's not vital at all. It's definitely not necessary. But if I go over here, I get that 4 is greater than or equal to 3. Is that a true statement? Is 4 greater than or equal to 3. Yes, that is true, right? I didn't get something like negative 4 is greater than 3, right? I didn't get 3 is, no, actually, well, 3 would have been fine because it's equal to, but I didn't get something like 4 is greater than 5, right? That would have been a false statement. Here it is true, though. 4 is greater than 3. So I know that this is my true side. This is the side I need to shade. Because one test point worked on this side, all the points will work on this side. And there we have the graph of the inequality. So an inequality graph does not only have a line, it has shaded side. If you've got more than one equation, as we will see later on, it's got a couple shaded sides. Okay, good. Or it's got like one shaded zone, but every single inequality graph is going to have some shading on it. Let's try another one. I encourage you guys to stop the video now and give this next one a try. Your equation is x equals 3y is less than 4. Okay, so hopefully you stopped the video, right? And hopefully you got questions answered, things like that. So I'm going to go through and we're going to do this together. So we've got x minus 3y is less than 4. We need that in y equals mx plus b. So move the x over, you got negative 3y is less than negative x plus 4. Now we divide by negative 3, and we are dividing by a negative, which is going to cause a problem, right? We got to switch that sign. So now y is greater than positive 1/3 x plus, minus 4/3, right? So we got to watch out for that. We've now switched the sign because we were dividing by a negative. So now y is greater than, okay? That, again, it's not something that's guaranteed to happen. It's just you have to watch for that. If you end up dividing by a negative, you're going to have to switch that sign. All right, so we'll start by graphing it like it's equal. We'll go over here and go up to our y-intercept. This tells us our y-intercept is 0, comma, negative 4/3. And so we want to go, it goes down one whole thing and then about a third more. All right, so that's our y-intercept. And then we'll go up 1 and over, up 1 and over 3. So up 1 back to a third and over 3 to like right there. And I want to pause before I draw my line. So I've graphed this like it was equal, right? So it started at negative 4/3 and then I went up 1, which gets me almost back to 0, but not quite. I still have another third to go. And then over 3. Alrighty. Now, it's a strictly greater than, meaning it is not equal to. So I'll go and check my little box. It looks like I'm going to need a dotted line. So it's a good thing I paused before drawing this line. I need a dotted line. Kind of hard to do with the stylus, but I will try my best. Okay, so a dotted line through this whole thing. And then I'll still throw the arrows on the end to indicate that it is in fact a line, right? But it's a dotted line. It means it's not, the stuff on the line is not true statements, right? But it's very, very close. Very, very close. All right, now I'll pick a side, right? I got to pick a side to shade. That would be the last thing. I can kind of tell that since this is greater than, it's probably going to be up here. But just to prove it to you, just so I show you what I mean by something that doesn't make sense, I'm going to pick a side that I think is not the right side. So I'm going to pick a test point on the side I think is not correct. So I'm going to pick this point right here, this pink guy, which would be negative 1, 2, 3, so 0, comma, negative 3. That's the side I'm going to pick. You know what, I'm going to write this over here. My test point is going to be 0, comma, negative 3. I'll plug that into my point here. Again, I kind of purposely chose zeros because it's in y equals mx plus b, and that's going to get rid of the 0 part. But I can look, any point would have worked. I could pick this point, I could pick that point. It totally would have been fine. Any of those would have worked. But I just like to pick something that ends up being mathematically easy. So I have negative 3, if I plug this in, is greater than negative 4/3 times 0. I'm sorry, not 4/3. It would be positive 1/3, right? So it'd be 1/3 times 0 minus 4/3. That cancels out because it's times 0, so I get the statement negative 3 is greater than negative 4/3. Now, negative 4/3 is negative 1.3 repeating. So is negative 3 greater than negative 1/3? And I have to be careful because it's negatives here. But no, it's not, right? Negative 3 is smaller than negative 1/3. So this is a false statement. That doesn't mean I have to go find a test point that's true. That just means I know that this point is not on the shaded side. Therefore, the shaded side must have been the other one, right? It must have been this one. Again, I can use logic, and that's fine. But if you're even the littlest bit unsure, a test point can always help you out. So this is what our graph would look more like. I want to say it's definitely not including this point here. That is not part of it, right? All right. Hopefully you got the same thing. Let's move on. All right. Let's do another one. So 4x plus 2y is greater than 8. So same 3 steps. We've got 4x plus 2y is greater than 8. Right? 4x plus 2y is greater than 8. First, convert. First, we will convert it to y equals mx plus b. So we'll subtract the 4x from both sides. We end up with 2y is greater than, right? Now I didn't, just because it's a negative, just because it's a minus 4x does not mean I need to switch it, right? I didn't divide. I didn't multiply. I just subtracted. So that sign stays the same. Negative 4x plus 8, right? And then divide by a positive 2, and since it's positive, again, that does not change. Y is greater than negative 2x plus 4. Alrighty. Now we'll graph it like it's equal. So start at 0, 4, right? That's what this tells us. 0, 4. So 0 out and 4 up. 1, 2, 3, 4. 1, 2, 3, 4. Yep, there's 0, 4. And then I want to go down 2 over 1. Remember, a slope of negative 2 is negative 2 over 1. So down 2 and over 1. All right, now pause before I draw my line. But, got to make sure that I've graphed that correctly. So I start at 0, 4, and I go down 2 over 1. Alrighty, now what kind of line do I want? Well, it's a strictly greater than, just like the last problem where it was a strictly less than and turned into strictly greater than as well. So strictly greater than is going to be a dotted line. A dotted line. Going down this thing, right? Sorry about the stylus being a little hard drawing a dotted line. Not the straightest line in the book, but that's okay. So dotted line, right? Don't want that straight, don't want that solid line. Now it's okay, the difference between this problem and this problem, they're both dotted lines. This one had a positive slope though, and this one had a negative slope. So there is no correlation between whether your line is going up and down and dotted or solid, right? It's just dealing with the fact that this is a strictly greater than, right? Strictly greater than, just because if it doesn't have an equal sign, it's a dotted line, okay? I don't think that there's a coordination or correlation there. Last thing I want to do is maybe use logic to figure out which side to do, but if that doesn't work, I can use a test point. I'm going to pick the easiest point in the book, 0, 0. If it's not on my line, I can use it. I'm going to use 0, 0, right? So let's try 0, 0. In our equation, y greater than negative 2x plus 4. 0 is greater than negative 2 times 0 plus 4. 0. That gets rid of that. Is 0 greater than 4? Is that actually a true statement? No. That is false, right? That doesn't make any sense whatsoever. So I know that this side cannot be my true side, right? Because this doesn't make any sense, this can't be the side that's supposed to be true, right? So it's got to be this side. It's got to be that side. All the shading on this side. All right, looking good. All the shading on that side. All right, stop here if you have any questions, and stop here to try this next problem on your own. 3x plus y is less than or equal to 15. Go ahead and try that one now. Alright, so hopefully you've had a chance to try this one on your own. If not, then I sincerely hope tonight's homework is not too hard for you, but it's probably going to be. I'll go real fast. 3x plus 9y is less than or equal to 15, right? So we'll rearrange that into y equals mx plus b. Same format as the other ones, right? All four of these symbols have the same format. So we'll rearrange. We got 9y is less than or equal to negative 3x plus 15. That's pretty cool. And then we'll divide by 9. Again, it's not being divided by a negative 9, so I don't need to worry about the fact that I don't need to worry about switching the sign at all. They only need to if it actually happens, right? So y is less than or equal to negative 1/3 x plus, if we reduce that a little bit, that would be 5/3. Alright, now we'll graph this. 5/3 is it's almost 6/3, which is about 2. So this would be a y-intercept of 0, 5/3, right? Or 1.66, so up 1, almost 2 would be our y-intercept. And then this is a slope of down 1/3. So down 1 to about 2/3 and over 3, so right about there. I'm going to pause before I draw a line. Alright, so this line is, this equation is less than or equal to, which means that equal to is okay, which by our notes up here says that we need a solid line, right? Less than or equal to. So we're going to draw a solid line in between these two. I think I managed to get most of the graph, which is cool. And then I need to find out which side to shade. Now it's less than or equal to, so logic says it probably should be the lower part. But just to check, I'm going to pick a test point. I'm going to pick 0, 0 again. So I'm going to pick 0, 0. Because why not, right? So my test point of 0, 0. So 0 is less than or equal to negative 1/3 times 0 plus 5/3. That cancels. I get 0 is less than or equal to positive 5/3. Is 0 less than or equal to 5/3? Well, 0 is not equal to 5/3. That's true. But it's or, right? So it could be less than or equal to. 0 is less than 5/3. And since it's got one of the cases, that is a true statement. So if you've got one of those inequalities where it's either or, right? Less than or equal to, greater than or equal to. It's okay if it's equal to, and it's okay if it's just less than. Either one would be okay. So this one is true, and it looks like this is the side I want to shade. Now when you're shading, I need you to do me a favor. Do not go like this. Okay, that is not a shade. Do not go like that. No, I want you to take the time to shade the entire side. Shade, 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 shade. I need to know specifically which side you are talking about, because in our next concept, you are going to be shading not a side, but just one of 4 places, and I really need to know which one you're talking about. So I need constant shading. You see how here this entire side is green, and this entire side is orange? I want to see stuff like that. Shade the entire side, okay? Alright, cool. So we've shaded one side of the graph, which is fabulous. That's how you deal with one inequality. Now you really need to pause here if you are confused. If you have any questions at all, why didn't yours turn out like mine? What do you do if this, or that? You need to stop the video, you need to raise your hand, and you need to get your questions answered, because what we're going to go on to in just a sec is graphing 2 inequalities on the same plane, okay? So if you can't do 1, you can't do 2. Just trust me. You need to get your questions answered. Alright. So give me a sec if you need to pause the video. Alright, so now we're going to be graphing what we call intersections of 2 inequalities. Now, that sounds super complicated. It's not. We're going to graph 2 inequalities on the same plane, and then we're only going to shade the part that makes them both true. That's really the idea here. So both of the inequalities, that's what we're going to do. We only want to shade the part where they're both true, or shade the overlap. So let's take a look here. Sometimes you'll see it written like this. graph 2x plus 4y is greater than or equal to 5 and x is greater than 1. So they're basically telling you that not only is this a true thing, this is also part of the true zone as well. So let's take both those equations, and again, yours are probably lined up, mine are not, because I had to squish it down. So luckily yours are probably right there by the graph. But just in case, let's go ahead and rewrite them over here. So we got 2x plus 4y is greater than or equal to 5, and we'll even do it in a different color. X is greater than 1. And we're going to come back to that one in just a sec because I agree with you, it does look a little weird. But it's not too much different. Alrighty, so 2x plus 4y is greater than 5. Step number 1, let's graph this inequality. We're actually going to stop before we start shading. So don't shade yet because we don't need to shade the whole thing, right? But let's go ahead and graph this one. Okay, we just did that. Alright, that's not fun. Alrighty, so let's go ahead and graph this. So we rearrange. Got negative, whoops, it's going green. So minus 2x to both sides. You get negative 2, no you don't. You get 4y is greater than or equal to negative 2x plus 5. That's what we get. Divide by 4. And we can see that y is greater than negative, seriously? Y is greater than or equal to negative 1/2 x plus 5/4. Alright, so that's where we're starting. This gives us a y-intercept of 5/4, right? And 5/4 is about 1.25. So we will go draw our y-intercept at 0, 1.25. So that'll be over here, and it'll be going out nothing, up about 1.25. That's our good starting point. And then our slope tells us to go down 1 and over 2, so we'll go down 1 to about 0.25 and over 2 right there. Alright. And since it is less than or equal to, we will need a solid line. You can use a solid line. And then I'm going to pause right there on the green line. I'm not going to shade quite yet because I want to make sure that other equation gets on the graph first. So we're going to pause right there. Alrighty. So if you have a question, make sure you answer. Now let's talk about this other line here. Now this line looks a little weird, right? This equation looks a little weird. Who remembers what type of equation? If this was, in fact, x equals 1, what kind of line would that be? That's right, it'd be a vertical line through 1, right? And that you need to know. So this would be a vertical line through 1. Through 1, right? So let's go ahead and draw that like it was equal. Exact same process, right? We just need to know about those things like vertical lines, but they follow the same rules. Once you remember the rules about those, you remember rules about inequalities, you just put those two rules together. So x is equal to 1. So I'll go over here, I'll find x is equal to 1, it's right about there, and I'm going to draw the vertical line that goes through there. X is equal to 1. Done. Sweet. And I know it's supposed to be a solid line because it's also greater than or equal to, right? So I drew a solid line because of the same rule as why I drew a solid line for the other one. Excuse me. Alrighty, so now I need to find a place to shade, right? So now I need to find that shading zone. Now you've got one of two options. You can shade for the green, you can shade for the orange, and then you can indicate where you find the overlap. But I find that that's a lot of shading, when in reality, the only thing we're looking for is the overlap part, right? We're looking for where both of these are true. So let's take a look. Where would both of these be true? Well, logically, this one says that the green zone would probably be this upper triangle, and that the yellow zone would probably be anything greater than over here, right? But just in case, let's pick a point. Let's pick any point we want. I'm going to pick, let's pick a zone that's in neither one. So let's pick a zone that's here. Let's pick 0, 0, because we've been using that a lot. Let's test out 0, 0 in both of these. So we're going to test out 0, Here we go. 0 is greater than or equal to negative 1/2 times 0 plus 5/4. That makes that go away. We get 0 is greater than 5/4 or equal to. Is 0 greater than or equal to 5/4? No, that is a false statement, right? Let's test the other one out. 0 is greater than or equal to 1. Is that true? No, that's not true at all. So both of these give us false, right? And we kind of figured that from the get-go. Neither one of these we said was the true zone. So they both gave us false statements. So that's definitely not something we want to consider, right? And this is kind of why I didn't want you to use X's when you shaded. I wanted to make sure that, you know, if you were crossing out a zone, you weren't telling me that's actually the zone. But let's pick a test point in the zone we think is true, right? Let's pick, I don't have any 0 zeros in there, which kind of sucks, but that's okay. We'll use this point right here. That's the point 1, 2, 3, 4. So the test point 4, comma. See how far I have to go. 1, 2, 3, 4. So it's actually 4, 4, which is kind of convenient. Let's test that out in both of these. So 4 is greater than or equal to negative 1/2 times 4 plus 5/4. Let's see. Okay, so 4 times negative 5 or times negative 1/2. That's going to be 4 divided by negative 2. So negative 2 plus 5/4. Well, you can do it as a decimal because we're not really concerned about graphing. So that's 4 is greater than negative 0.75. Is that a true statement? Yes, 4 is definitely greater than. Now again, it's not equal to, but that's okay. It's got to be one or the other. That is a true statement. Let's look at the other one. 4 is greater than or equal to 1. Is that a true statement? Yes, 4 is definitely greater than or equal to. Notice we got both true. For these guys with two equations, you need both of them to be true. One ends the game. So if we had gotten that the first one was false, the second one was true, then it wouldn't have been the right zone. But if we got true, true, like we just did, then we can say, yes, this is the zone we would like to shade. Both of our equations gave us true, true, and so that is the equation we want to shade. All right. I'm going to let you guys try out this next one. Go ahead, try it out, see what you think, and then restart the video, or unpause the video when you have figured it out. Alrighty, so I hope you had a chance to pause the video. Let's take a look at these two equations. So these ones, we don't have any of those horizontal or vertical ones, which is nice, right? But it's the same process. So it's the same process. Nice. We're going to kind of divide this area up here so we can keep our thoughts straight. First equation is 3x plus 9y is less than or equal to 15. Luckily, we've already graphed this one today, so we kind of have an idea of what it's supposed to look like. But just in case, let's rearrange it. So we've got 9y is less than or equal to negative 3x plus 15. Negative 3x plus 15. Awesome. And then we divide by 9. You get y is less than or equal to negative 1/3 x plus 5/3. Alrighty. We'll start by graphing that one on there, right? So 5/3 is again about 1.6-ish. So we go up to 1.6. And then our slope says we go down 1 and over 3. So we go down 1, back to about 2/3, and over 3 to right about there. And it is a less than or equal to, so it's going to be a solid line, right? Solid line, a solid, oops, and you're going to draw it a lot better than that because that wasn't even close to the line you wanted to get, right? You want to get at least through the dots. Doesn't have to be perfectly straight, but we at least got to go through the dots, right? So we got solid line. And then we will wait to shade. We'll wait to shade. Our other line looks like 4x plus 2y is greater than 8. We'll rearrange it a little bit. Subtract 4x from both sides. We get y is greater than negative 2x. Oh, I'm sorry. Just kidding. I'm way ahead of myself. So we'll undo that. So subtract 4x from both sides, you get 2y. It's greater than negative 4x plus 8. And lastly, we'll divide by 2. To everything, remember it's got to be to everything, greater than negative 2x plus 4. Alright. This is a y-intercept of 0, 4, so up 1, 2, 3, 4. And then down 2 over 1 is our slope there, right? Because this represents a slope of negative 2 over 1. And I'm going to pause because, and this is very important, so before now, everything has been greater than or equal to, or less than or equal to, so a lot of solid lines. But notice here, that is a strictly greater than, so this is going to be a dotted line, right? Dotted line down the graph. So watch out for that, because I see people make that mistake all the time, and then they got to start the problem over, especially with online homework. All right, cool. Now we've got these both on here. We need to find our true zone. It can't be one or the other. So we've got a less than, which says probably in the blue we're going below, and greater than, which probably in the red we're going above. That would probably be, let's see, below and above would be right about here. So let's pick a test point there. But just to show you what would happen if you didn't quite pick the right one, let's do one over here. Let's pick this one, just to show you. Alright, so that would be the point 3, 2. 3, 2. So let's test that point out. We're not going to use blue, we're going to use purple. So this purple point right here is going to be the point 3, 2. We're going to try that out. So y would be 2 is less than negative 1 over 3 times 3 plus 5/3. 3 and 3 cancel. So I'm left with 2 is less than negative 1 plus 5/3, or 2 is less than 2/3. Is that a true statement? No, that is not a true statement. That is a false statement, right? So, oh, and I'm so sorry, this should have been or equal to. That's a false statement. Let's test the other one now. Probably not going to do this problem, so we'll go into this one. 2, nope, just kidding. Yeah, so y is 2 still, is greater than negative 2 times 3 plus 8. 2 is greater than, wait, 5/3 minus 3/3. Yep, okay. 2 is greater than negative 6 minus 8 would be 2. Is 2 greater than 2? 2 greater than or equal to 2? Oh, no, just greater than, sorry. Wait, what? Hold on, I may have made a mistake here. 3, 2. It's not plus 8. That's why it's plus 4. JK, JK, LOL. So plus 4, right? So now we have 2 is greater than negative 6 plus 2, or negative 2. Is 2 greater than negative 2? Yes, it is. So this is a true statement. So we get that the red is in the true zone, right? But the blue is not. We chose the wrong side for the blue. So that's definitely not the zone we want. We don't want to say this is our true area, right? And we kind of figured that out, but that's okay. So we have a false. Anywhere you get a false, it's automatically done. So if you had figured this out first, you could stop. You wouldn't even have to test that second point. But just to show you that that's what would happen, sometimes it's a deal breaker. So let's test out a point that we actually do think is true. Let's test out a green point probably right about here, where that's at 4, negative 1. So let's test out 4, negative 1. Again, you do not have to test it out as long as you think you're 100% sure. But if you're even a little bit on edge about it, I would test out a point that you think might be true. So let's test it out. We've got, I'll start with the blue side. So 1 is less than or equal to negative 1/3 times 4 plus 5/3. Is 1 less than or equal to, let's see, that would be 4/3 minus 5/3. That would be 1/3. Oh wait, what did I do wrong? Because it should be lower then. Oh, -1, I'm sorry. -1, yeah, our point was for -1. So for -1, so -1 is less than or equal to -1/3 times 4 plus 5/3. Is -1 less than 1/3 or equal to? Yes, that is a true statement. Now we'll test out the other one. Is -1 greater than -2 times 4 plus 4? Oh. Plus 4? Well, that means -1 is greater than -8 plus 4 is -4. Is that a true statement? Yes, -1 is greater than -4. So we get true and true. That looks like that must be our zone that we want. So just this little triangle right here is the zone that we want, because that's the only place where these guys are going to give us true and true. All right. Okay, so I had to restart the video from here because I ended up changing the last two problems, and I wanted to make sure you got the right one. So we're going to start on 3.1 here. This one is a little different than the ones we've seen in the past. Not too different, though. So we're going to graph these just kind of the same way. I have -3x plus 3y greater than or equal to 6. Now at this point, I hope you can kind of see the routine, so you can graph this one pretty fast. We're going to change that to slope-intercept form. Y is greater than or equal to x plus 2. Okay, so I'll go over here and graph that one. And that is a slope of over 1 up 1. Now, in case you haven't talked about this yet, not having anything in front of that x there, remember that means it's a slope of 1 over 1. We just get lazy, when we don't write 1 there. So it just means slope 1 over 1. And it is a solid line. Okie dokie. Okay. Now this next one is really what I wanted to include. Y is greater than -1. Now we talked about one of these earlier, right? It was x is greater than or equal to 1, right? Same kind of idea here. This is something I have to recall from previous chapters. This is going to be where y is -1. So we want to go to the place where the y's are -1. And that would be y is -1. And it too is equal, greater than or equal to, so I want to make sure I put a solid line. Now in the rest of the video, I have mentioned the test point system. You're still welcome to use that, but if by now you're starting to get sort of an innate feeling about where it's going to be, I could show you a slightly faster method. Here we have 4 places to choose from, right? We have this zone here, this zone here, this zone here, and this zone here when it comes to shading. So 4 places to consider. Now if I think just about the blue line, that is a greater than or equal to. The equal to part is taken care of with the line, the solid line. Where are the things that are greater than this blue line though? The greater than ones would be, well, the ones that are above. So not this one and not that one, right? Those two are eliminated. There's no way those two could be my zones because for the blue line, those are less than, right? We don't want less than, we want greater than. Now I'll do kind of the same idea for the for the red line, pardon me. The red line, the greater than zone, would have been, well, the one that I just crossed out, or the one next to it, so it would not have been this one. And that just leaves me with my one zone. Now again, if you're not sure about that, if you don't have this same intuitive feeling, then please, by all means, go back to the test point system. But this is just sort of a faster way. Now when I mean by greater than, I mean the y is greater than, right? The y's are up here. From this point here, all the y's are greater than, and so this is where our greater than zone would be. All right, one last one, and then we're going to do a word problem. Okay, so let's just pretend it's normal. It is normal. Let's just keep going and do this one. So less than, less than 12, because that's going to change my line, right? We don't want to do less than or equal to, because that's not what it says on the page. So now we'll go ahead and solve this for y, because why not? Haha. Slope-intercept form is the easiest, and I have to be careful. When I divide that, that's not going to be 2, right? It's going to be 1/2, because it's not 6 divided by 3, it's 3 divided by 6. So we end up with -1/2 plus 2. Okay, and graph that like it's equal. down 1 and over 2. And then as I mentioned before, we want to make sure that's a dotted line. Yeah. Okay. We'll deal with the less than part later, right? So when we have all 4 together, that's when we can consider it's just clean. Okay. The second one, kind of same routine, 6x plus 12y greater than or equal to 24. Solve this one for y. Oops, pardon me, that was not a 4. Just move the 6x over, and then y greater than or equal to negative, hey, that sounds familiar when I divide by 12 there. Negative 1/2 x plus 2. Look at that, that's the same stuff to the right side, right? Now I'm not going to say they're the same line, because they're not, right? If you look at them, those are 2 different inequality signs. In fact, they're about as different as you can get. One of them is y is less than negative 1/2 x plus 2, and the other one, this one, is y is greater than negative 1/2 x plus 2. We're going to see how that plays into our shading. But I'm just going to graph this one as well. It's going to be right on top, but this one's going to be a solid line. Interesting. Okay, but now what does that mean about our shading? Well, for the blue line here, it could be the solid line or anything above it. That would be this zone here, right? So maybe this zone. But then for the other one, it's everything below. So where is it both? Is it just on the line? Do I just not shade it? Well, no, it's not even that, because the red one says I can't be on the line, but the blue one says I can. This one is in fact a very strange case of no solution. There is no solution here. This is one of the very few places where you not only get the same line, but it has no intersection point. There is no crossover here. It's interesting. Now that is not true of every time you get the same line, right? If they were both less than, I'd be fine. I can just shade both below, right? And I'm good. I just happen to have the same line twice. And we're back to an example from before. But this one is a very rare case where it's actually nothing in common because one of them is bigger and one of them is less than. Interesting. Okay, last thing we're going to do is see one of these things in play in a word problem. So, Janessa is creating props for school play. There's furniture and handheld props to make. First, she must construct the prop out of wood. It takes 10 hours to construct a furniture piece and 6 hours to construct a handheld prop. She has a maximum of 102 hours to spend constructing. Next, she must paint the props. It takes 11 hours to paint furniture piece and 12 hours to paint handheld piece. She has only 123 hours to paint all the props. Okay. That's a lot of information. When I get handed a huge paragraph like that, I like to use something called translate, solve, translate back, because math is an entirely different language. It is about as much in common with English as, Japanese. So we have to make sure we put this in math class first, because English, the sentences they've given me here sound like they relate nothing to what we've talked about, right? We have to put this in context of class. Now, if you can do that, you've got pretty much 3/4 of the class down. Okay, if you can change a paragraph into math, then you're golden. You can solve any problem. One first thing that I see is that they keep talking about these two things over and over and over and over again. Furniture and handheld props. Okay, maybe let's call this X and Y. Because those are the things that just keep happening over and over, but those are the things we also don't know a specific number for. We don't know how many furniture pieces, we don't know how many handheld props she has. We're just told how long it takes to construct them, right? Okay, so now I see another kind of duality here. I see another thing that keeps happening. She keeps talking about constructing the prop, but then also painting the prop. And there's a lot of information about each of these. And to me, that sounds like a situation number 1 and a situation number 2. Right, the whole situation about constructing the props and the furniture, and a whole situation about painting the props and painting the furniture. Right, and they give us a lot of information. So to me, those sound like 2 different situations. In fact, they sound like 2 different equations. So maybe I want to make an equation about constructing and an equation about painting. All right. the constructing equation. Let's read again all the information we got about constructing. It takes 10 hours to construct furniture and 6 hours to construct props, okay? And then a maximum of 102 hours. Okay, so what I'm hearing is 10 times a furniture and 6 times a prop, right? Because I made X furniture and Y props, right? Now, how do they relate to the 102? That's the big question. Well, total usually means add them all up, but it has to be a maximum of 102. If it was just equal to 102, that'd be okay, right? So let's kind of look at individually. Could she take exactly 102 hours? Yes, that would be totally fine. Boop. Could she take 101 hours? Yeah, that's underneath, right? That's totally fine. She could take less time. Can she take 103 hours? No, now it starts cutting into her schedule. So it looks like everything equal to 102 or less than. It must mean that a maximum interpreted as less than or equal to. And that's how we get our inequality. I'm going to pause. You don't need to pause the video, but I'm going to wait right here for about 10 seconds, and you're going to come up with the painting equation. That's what I love about these problems, is you get kind of a dual chance. Okay, here we go. Okay, so I hope you read the problem again and said it's 11 hours to paint furniture gives you 11x, plus 12 hours to paint furniture gives you 12y, and that is a maximum of 123 hours, so less than 123. Hope that's what you got for the painting equation. Okay, let's go ahead and graph these now. I'm going to give myself a pretty big graph here. Now notice I'm only putting on the first quadrant. I'm only putting on the first quadrant. Because, I mean, I could draw all 4, but I'm not going to end up using them. And in fact, it would be wrong to end up using them, because what am I talking about? X's is furniture. Y is props. There are no such thing as negative furnitures and negative props. You can have 0, which is indicated right there, right? But you can't have negative pieces, so it doesn't make any sense to make these equations go into the negative zone. Alright, so now let's go ahead and maybe just solve these guys real fast for y. 6y less than or equal to negative 10y plus, negative 10x plus 102. Y less than or equal to, it would reduce to 5/3, but let's just put it as a decimal. Negative, we'll do 5/3, it's fine. X plus 17, okay. And then the other one, 12y less than or equal to negative 11x plus 123, divide 12. The reason I'm leaving these slopes as fractions is because they are just that, they're slopes. We want to make sure we can go down 11 and over 12, right? And then 123, 123 divided by 12, and we'll just do 10.25. I could make it a decimal, or a fraction, pardon me, but this one I'm just counting, so it's fine. Alright, so we'll call this x, y, or even better, we can call this furniture and props, right? This is the combination of the two. So now, let's see, let's make this go by, let's go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and then over here, okay, let's make this one go by 4s. This is going a little fast. 4, 8, 12, 16, 20, 24, 28, 32, 36. Alrighty. Okay, so the first one, start at 17, which would be right here. We go down 5 and out 3. And it is or equal to, right? We said that that was okay because she could take the full amount of time. I can't get this to line up. There we go. And I'm not going to extend this into that push because it's not negative, right? Okay, and then the next one, start at 10.25 or, 10-ish. 2, 4, 6, 8, 10. It's like right there. Come on. And then down 11 and over 12. So down 11 and over 12. Okay, now I'm not actually going to connect to that dot, but I'm going to kind of eyeball it to the end here. Right? Because technically it wouldn't be negative, but that's where it would go. All right, and then a negative, negative. I'm just going to do this less than, less than. I'm just going to do this intuitively. Both less than zones would be here. And we have a graph, beautiful graph. Now, what is this graph? What are we talking about? We're talking about the possible combinations that she could come up with. For example, 4, 2. She could make 4 furniture pieces and 2 props, and she would be within her time frame. What she can't make is, 16 props and 20 pieces of furniture. Or sorry, 16 pieces of furniture and 20 props. She would not be able to do that given her time constraint. All right. Okay, so that's inequalities. If you have any questions at all, shoot me a message on Canvas or email me. See ya.